Welcome all. Yeah, Rob asked me to talk a little bit about or OSS Review Toolkit, or for short. And yeah, since I was anyways doing another deck for another presentation that I have to do for a bank, I was just basically I'm reusing a little bit of my slides. So the question there was like, hey, why are OSPOs using and contributing to ORT? Speak a little bit of background of whereabouts. Maybe first a little bit about myself. So many of the OSR members know me because I've been in FINOS for quite a while. Yeah, I forget to ask the FINOS logo here. I should have asked the FINOS logo here. Yeah, my name is Thomas Steenbergen. I generally help organizations with all things open source. I'm the former head of the Open Program Office at EPAM and at here. I am a maintainer of course, ORT. I am also a OSPO ambassador. So that's actually where I mostly join the OSR meetings as well. So I'm very active in to-do group. I organize several events, mostly in Europe, like Ospology Live. So yeah, I'm actively working on getting OSPOs everything what they need, from tooling to knowledge sharing. Really, I'm trying to help the whole topic forwards. I thought to start simple because I never know who shows up to an OSR call and also and I was explaining this to another bank in the Netherlands, and they wouldn't need to. So I made it extra simple. So I just reused the slide that I just made for this bank to explain it to them. So imagine that you have a very simple workflow. A software product is a little bit simplified, where you have your internal developers basically working on code repositories, and they build code, they release software, they product releases, and then it goes to customers. But as you see, there are lots more other components that are coming in. It's not just the software development team, but there may also be, as you see on top, things that are developed by your own organization. There might also be third-party source code or third-party packages that go in, or sometimes even third-party product things, for instance, SaaS services. So there's a lot more things going into a product release that goes to customers. And if you work in an OSPO, this some challenges, and this is how I made them all nice dark clouds, because there's so many things that basically a regular open source program office has to think about. And there are the known things, of course, okay, security, which you see everywhere in this cloud, but there's also topics like licensing, like what are we including, like not only open source licensing, but also like third-party licensing. Funny enough, the longer I've worked for OSPOs, the biggest headache is not necessarily open source licensing anymore, but it's actually more the closed source or faux open source licensing. So that's our licenses that smell like open source, but are not necessarily really 100% open source. And then, yeah, health is also becoming a much more a bigger topic, like making sure that what we're using is sustainable. But it's all over the place. There's so many different topics, and including things like, which I didn't even know about when I started this topic, but we had contracts with our customers, and the customer says, yeah, we will purchase this product, but we need to get the source code in escrow. Oh, and it needs to be the complete corresponding source code. Yeah, that's not something basically most developers think of. So then you need to figure out how to get the complete corresponding source code for a particular package so we can ship it. And funny enough, that's the same thing that we had to do to comply to some of the projects that were under a copyleft license. So there's lots of things that basically for OSPO are challenges that are all coming together that we had to deal with. So I was fortunate enough that basically I used to work for Nokia, and I started working for the Heroes program office the moment our company basically here got split off from Nokia. So I had a blank slate, and we really started looking at like, how can we reimagine, build this pipeline? How could we really automate, do everything? Because there was a difference between our company. We were here with a mapping company. It's more a software company. Nokia at that time was more a hardware company, aka mobile phones, or nowadays they're still mostly telecom equipment. So it was a completely different business, and we were more software driven. So then we're looking at what are all the questions that we have that are common inquiries that we get as an open source program office. So I racked them here up. Most people think there were, yeah, of course, when we began, there was a lot of licensing and security questions. But actually, since I was part of the CTO at the time, actually, most of our initial questions were actually from within the CTO office about who's using what, who has what skills. Because our CTO at the time was really interested in figuring out, now we're a separate company, how can we reorganize our engineering to be basically be more effective? And where, after the split, do we have gaps in our skills? And so That's how we got started when we started asking all these questions. And then we were like, okay, we do all the stuff. And then we were like, okay, then we have open sourcing questions, then we have business continuity questions because, hey, we're the mapping company. In case we don't deliver a map, literally, or some services go down, literally, your Amazon package, for instance, will not get delivered because that's powered by some of our services. And if the delivery driver cannot find your front door, you have a problem. And later on, we also started looking at inner source questions, and that basically had to do with engineering best practices and other related best practices where how you organize squads. So again, once we have identified we're there, you have skills gap. Now, how do you get skills to particular teams, and how do you get one side of the company to learn from the other side of the company? So whilst we were looking at this, we're looking at, okay, how can we best build a review process to get this whole software engineering stack of things? And then we were looking, okay, now we need something that supports all the package managers. We want to get all the data and basically do a risk-based policy because we already knew that basically all the various parts of the company were doing different things in different entities. And there was not a simple, oh, you can just approve this license and then everything is fine. So just this license thumbs up, thumbs down. We couldn't really do that. We really needed to bear a more bespoke model, and we needed exceptions because the company is a global company and the rules in China are different than the rules in EU. And so you had all of these different things. So, and also the risks from various things that we were doing. We had things that we're doing in basically internally, and maybe or we're doing in a labs environment where basically we quickly work together with a partner to build something innovative. And then we had things that were shipped into a car. And you didn't really want to have the same policy that is applicable for a car, where you have really, cars can kill people. So the laws applicable to software that you ship in a car are really tough. But you don't want to apply that to something that's just an experiment internally to see whether they can do a new map matching engine or something like that. Plus, we ideally wanted to have something that was end-to-end traceable, and that had to do with all kind of regulation and things. If something goes boom, you need to be able to prove to the auditor and how you react to that, how you can trace it back. So you need to know what's happened. But of course, with the review process, developers are your customers. So they are already overburdened because we were ourselves also developers ourselves, and we knew already that we didn't want to overburden developers and that they would just get fatigued with all the tests. But because that was one of the things that we already quickly figured out with the other processes, there was lots of paperwork, lots of checkboxes, but effectively, it didn't really work. And so what we wanted to do was a more simple self-service model that developers could easier learn regardless of the technologies. And you might wonder, why am I saying this? So cars, you have embedded software, and on the other side, we had our platform guys that make our backend services. Unfortunately, the way how these setups are, they're so completely unique. One is in Java, the other maybe in C, and they have completely different stacks. And that usually resulted in that the development stacks of these two teams were completely different. Yes, they might both use Git, they might use but they use completely CI, completely different workflows, because simply these were different engineers that come from different environments, so their environments, their ways of working were completely different. But for us, we wanted to have something similar because all the supporting services like legal, like patent team, like security, all of that need to interact. So we started evaluating tools, lots of tools. I still to this day keep track of, God knows, it must be now more than 150 plus different SCA, SBOM tools, or other generic OSPO metric tools that I keep track of and follow. But unfortunately, I have to say there's no silver bullet, one that rules them all. Multiple times you need to mix and match. And that's what we quickly figured out. And I'm talking here, this is back in, God knows, 2016. We already figured out that basically, no, we need this for this, we need that for that. But that became, of course, a problem, because if you want to make a single pipeline out of all of this stuff, or a single interface, you cannot say, oh yeah, embedded engineers, for you to do your security and licensing, you need to use this tool. And then for the backend guys, you need to use that tool. Yeah, and then you come to legal and security, and then they have to every time need to do a new turn. So basically, we said, like, we want to mix and match. But then we figured out, whilst we were testing like our initial ideas and we're building a prototype, we already found lots and lots of issues that really come down to missing data and missing tooling. So open source, because it's free, doesn't mean it's perfect. You get what you're given. So yeah, lots of known issues with incorrect package metadata. So the source code location was incorrect, the licensing was incorrect, or this might surprise people, but things that are published on the internet do not live forever. So we had tons of open source packages where the sources were simply no longer available, especially in the embedded side, but also in the good old Java stack. There are tons of packages that are published on Maven Central where the sources are simply no longer available. And especially if you're looking at niche packages in mapping, this happens quite often. Then we came into all kinds of ways of working issues where, yes, on paper, we have tens of teams that are building Java, and you would think that they're all working the same. No, they don't. Each team works in a different ways of working, and simple things as what is the namespace for our packages? And now you're wondering, well, like, why is that important? If you want to do things at scale, you need to be able to separate out, these are my packages that are of our organization. These are third party, where they're closed source of open source. So it would really help if you have one naming scheme for all your packages. I'm not talking about versioning. That's a whole different discussion, but just one naming scheme of packages. And that was already a big issue where, because the company is multiple sub-companies, subdivisions, and there would be many different ways on how people would name packages. So then we had build and dependency tool issues where we were close to using 40 different build tools, because again, it's no longer, oh, we're only a Java shop. No, you use Python maybe for AI, you use Node for your website, you have an Android app, you have a Swift app, mobile app. So before you know it, build tools proliferate like crazy. And yeah, this gets really difficult because most of these build tools are not designed to basically get the information that you would need for your false views. And if you look at the end, you get a large amount of results. If you get all of this data, you get so many results from all of these SBOM tools. Yeah, what do you do with it? Like, how do you make sense out of this? So that's where we started looking together. And this is where we eventually decided from like, no, we need to build something ourselves that basically builds on top of other tools and makes a pipeline where we can do our policy automation and orchestration, so we get things that work end to end. And we just don't want something that just checks, but we also want something that satisfies the obligations. So taking away the burden from the developer and basically saying from, oh, your licenses require that you provide an open source notices file with all the licenses done. Okay, we'll just generate it automatically for you. Oh, this customer wants that you provide an SBOM. Yeah, we'll do this. Oh, this customer wants you to provide a reporting of all false components in their specific PDF format. Okay, cool. We'll do that. And that's really where we started adding value when we started building ORT, because again, here at the time had close to 400 different customers with false reporting requirements. Remember, this is the German automotive industry, and here also has a lot of automotive customers, and it's very standard that you have to report your open source that's included, but every organization, every customer had a different way of reporting that. And yeah, the contracts were signed, so we just have to do that. So that's why we created our tooling. Eventually, it moved to the Linux Foundation in 2019. Just a quick overview of what ORT can do. And so most people think it's an SBOM tool. It's actually, yes, it can generate SBOMs, but that's more an output of it. It's not necessarily the main thing where it is. It's really meant, yeah, to be more an OSPO-like tool for our end-to-end workflows. So yeah, the SBOMs, again, as I said, we had hundreds of different customers all wanting their own thing. Eventually, I started just lobbying to basically, like, hey, go to the more CycloneDX, SPX format so that we can make things more machine readable. That makes things also easier. And especially thinking in the automotive industry, Mercedes or Volkswagen doesn't build everything in your car. There's a whole supply chain in front of that. And so what we often had, if you're a map provider, you're in what we call a hamburger. So you're basically providing something, then another integrator builds something on between, and then it comes back to another team within your company. So we had this kind of hamburger slices where different companies in between things went in out of the company that come in with another team. And so it was, yeah, really difficult how to make things work end to end. This also came us to the next point. What we did is we needed a policy as code. So we wanted the ability that we could just take the policy that we had in our organization or to our customers and basically say, hey, write how you think about how the false reporting, just write it as code that we can then import into our instance of ORT. You might think, why is that useful? Again, think of a supply chain. And you want to have trust in the supply chain. You want to make sure that end to end, that if a feature is written by a supplier like 10 layers deep from where it comes to the car manufacturer, and you want to block a particular, I don't know, you want a particular package cannot be used because maybe it originates from a country that is on the block list. You want to be able to just write it in the policy rule as an OEM and just publish that policy to your suppliers, direct suppliers that you have a relationship with. And then you can ask your suppliers to basically, hey, give it that policy also through to your suppliers, and then give it to their suppliers. Because remember, the OEM that eventually builds the car doesn't have a relationship with all of the suppliers. So this is why if you have a policy that is just code or like can be separated from a tool, that's really useful. No, so then we had for source code archives, we needed that for licenses. And a major thing that we needed to be able to correct the package metadata and license findings. This was a very important thing because there's many tools out there that spit minute results, but the company is liable for what we report to our customers contractually. So if you basically report incorrect data to your customers, yeah, you just get dinged for it. And that are severe contractual penalties. In the worst case, if we got something wrong, it may be a recall of a vehicle, and which means that the damage can go into the millions. And so we really need to be able to correct any, and we also wanted to have something that we could do this in a more collective way. I will tell later on how that looks like, but we wanted something that scales better to fix these things. So this slide I added recently, like why choose ORT? Because ORT is a quite heavy solution compared to maybe some of the other tools out there. And yeah, it has to be doing with like the ideal situation is a high compliance environments. That's where mostly ORT is being used. So in the automotive, telecom, defense, that's where basically people that need to get it right and that have to do with like big supply chains where there are multiple parties involved that to create a product. And so they need high quality software bill of materials. But this is also quite common, especially in automotive and telecom. If you see a car manufacturer, if you look, for instance, like the Volkswagen is not one company, it's a whole group of companies. And for legal reasons, they cannot always share the same solution. It's very complicated, but we have similar issues as well, where we have certain restrictions on what we could do, for instance, in China or Japan. So having an open source solution where you can just say, download this from GitHub or from and just run this, and here you have the policy, makes it very easy, especially if it's highly modular and extensible solution, you could really build the things that you need. So that's very useful instead of having a SaaS solution, because as I said, if you run a SaaS solution, if you purchase that as a car manufacturer, you cannot share this with the vendors, suppliers. You get into all kinds. You cannot tell to your suppliers, oh, you need to use this tool. You will get in all kinds of legal trouble if you do that. Why not? Again, I always add this to be clear. Yeah, there are other tools, especially if you look at SCA and SBOM tools. There are tools most of the tools are focused on security. So they basically do more of a best effort and speed kind of check. I simply use this now. So for instance, now I'm doing SBOMs for FINOS. The first things I use other tools to basically get a gist of what is in running in the FINOS organization and where are the pain points. And so similarly, if you build workflows pipeline, you need some people, you need some engineers to build solutions. And this is where I sometimes, look at commercial tools like, oh, it's just less than a day to get it up and running. Yeah, that's all nice, but what about the results and the quality? And it always costs more time doing things. And of course, because ORT is an open source project, you do have to be able to work within the open source community, although there are commercial support providers. Oh, and this is more importantly, we don't support scanning Docker and operating systems. Very simply said, and I'll keep it brief, Docker is not designed to do any kind of compliance review. It's just a blob of binary blobs. It's just architecturally an absolute nightmare to create SBOMs for. Anything that you do with scanning Dockers is really just a finger in the air and getting a best effort approach. It's just simply how it works. You have to do it the other way around. The best way is to build your own Docker containers from scratch to get the best, to know what's actually in there, which kind of defeats the purpose of using Docker. Who's using ORT? I mentioned it's mostly automotive OSPOs, but there's also a wide variety all across which started adopting so far that I can't keep track of anymore. Like known adopters are listed here. As that there are Alliander, which is a major net provider in the Netherlands, Bosch, Cariat, so it's Volkswagen, Deutsche Telekom, EPAM. That is mostly the people that basically were close to us that started using it because we're all running into the same problems as OSPO. And in Germany, there's a big group of OSPOs that basically work together on their shell problems. Like you have here the OSR group, there's something similar kind of happening in Germany, but mostly between automotive companies, trying to solve their shared open source challenges. Just to give you a kind of the insight of like where there are also other FOSS projects leveraging ORT. So here, for instance, is the double open. It gives you a more traditional kind of, I don't know if people are familiar with fossology interface, so you can more see the source code and you can also implement there's different views. And there's also now Eclipse IPOPIS, which is an ORT server, which is really bringing ORT to bringing ORT to a cloud native instance, so you can do scaling more. As that it's really now multiple things. ORT project itself provides the core technology, but multiple different other open source projects have built different solutions for their various industries on top of it. Give you a gist of how the pipeline normally looks like and all the various components that make up ORT. So we thought actually, and this is literally what you see here is literally what we drew up on a paper napkin in a beer garden, how the tool ideally should work. It starts, and this might sound funny, it starts with the developers defining a simple YAML file. Why? We need to know from the developers, hey, for all the stuff that you are having your project, what is actually being shipped and what is not being shipped? Now you might wonder, hang on, you can just ask the compiler that. No. Most compilers are black boxes and you have absolutely no clue what from the input goes in the output. You could develop tools that do that, but they will be very compiler specific. And I know several open source projects and also commercial projects that have worked on this, on trying to make plugins for compilers to get all of this information. It's just really hard. So since we needed something that scales over multiple different package managers and build tools, we just basically said, look, we just create a simple YAML file, and I will show it in a minute how it looks like, so that people can just developers can easily indicate, hey, these and these directories in my source code repository are used for testing or for documentation. They do not end up in what's finally shipped to the customers. So it's a really simple way and scalable way for developers to just show that. Then it goes to our analyzer, which makes kind of a dependency tree. Then when we have the dependencies, we download you can download all the source code. So this download a scanner is optional. You can also go from the analyzer directly to the further steps. But generally, to get a good insight of what is going on, we download all the sources, and then you can afterwards put it to a multiple of licensed corporate scanners. So I know next week, I think Rob is False ID is going to do a demo. Not next month. Yeah. Okay. So then here you see again where we do the mix and match. So again, there were multiple different licensed corporate scanners that we wanted to use because different scanners were better for different ecosystems, or in this case, False ID is very good at finding snippets and that kind of stuff. So that's why we just combine multiple scanners into one scan result. Similar-wise on what we call the advisor, different security providers are better in different domains. So there are some that are, for instance, really good in NPM. There are others that are really good in the Java ecosystem. So we just wanted to basically buy API access from these various things and just tie these different things together. And this was the problem that I saw with a lot of the out-of-the-box solutions, is that they provide you a walled garden and everything is supposed to be in there, which is very convenient, but it doesn't always lead to the result that you really want to achieve because they don't have certain data or they lack certain. In this way, we can now mix and match. So for instance, they're now working, there's the black box security scanners for the OSV scanner is supported. So you can just pull in data from wherever you know the good providers are. So you always have the data, and then it all comes together in the evaluator. And that's, as you see the rule below, this is where you can write like an algorithm basically, where you can take all the various bits of data and you can write policy rules on top of that. And that really allows you to say, oh, for this product or team, because you can take different contexts in effect. I want to apply these rules. This license, I want to allow in this context, but I want to ban in this context. So it gives you really, really flexibility to write really all the rules that you want that really apply to organization, instead of you have one size fits all. It's also like dangerous because we have seen people that wrote like really big policy rules, and it becomes really hard to maintain. But yeah, this is the things where we got stuck. we had lawyers that were very experienced with open source. They knew exactly what kind of thing they wanted. But what happened basically is, they had a scanner do things with wings, and then they were doing a manual evaluation. Yeah, that works all fine and dandy if they want to do a manual evaluation, but it can't be if you have customers in Silicon Valley that say, no, we want at minimum 2 releases per day. Yeah, you cannot operate that fast. So then you need policy rules that can really separate out the code changes with our low-risk code changes, with our high-risk code changes. And especially if you now look at all the laws that are coming or are actually applicable to a lot of different industries. So we have the Cyber Resilience Act is, of course, the big one that's coming up. But you already have in financial services, you have DORA. And all of this new legislation, a lot of them are all risk-driven. And so what we just did is we basically know our risk-driven approach is, instead of writing this into documents and then developers have to read the documents and then do risk. Now, we're trying to have as much access to all kinds of data, suck them all in the evaluator, and just write computable rules on top of them. So that basically we can always show this is how the risk equation was done, and this is why this thing was approved and this one was not approved. Finally, there are the reporter component, which basically makes various formats. So I said you have the SBOMs, you have open source notices, dependency graph, source. It can do all kinds of things. And we have the notifying component. This is mostly for internal use, where you can send out like emails to a developer team if a build is stopped, or you can automatically create a Jira ticket. How it's integrated in the workflow, again, is relatively standard. You have a scan, you get okay. If it's okay, you can release. If it's not okay, basically the standard workflow is you ask for a code change. But now we get something different things. When you're not okay, it's like we have a code change of something we need to fix, but we also have, hey, the data might be wrong. So then we can make corrections. And you see, even security. And now you're wondering, huh? Why? So we have noticed from working years and years and looking at all the other stuff that a lot of data is just wrong. And it's just, there is just faults in it. And where, for instance, with security vulnerabilities, if you really know how they are created, the ranges of those are often not 100% correct. So then you have to correct this. Now you think, this is the responsibility of my vendor. Yes, we used to work in a mode where we just reported this issue to our vendor, but then the vendor had to fix this, and it would take a couple of days. This doesn't work if you work in an environment where you basically continuously have to ship. So we wanted to have a way that we could not have to make an exception, but really fix things pretty quickly and be able to ship all of the time. Again, if we don't ship, we don't make money. So we need to be able to ship, but we need to be able to ship at high compliance levels. So this is why we also have the next thing where we have our whole team of supporting teams, from the OSPO, from legal security to the patent team. They're all looped in all of these processes as well, so that they could instantly respond and quickly work with things. And one of the things I did here, for instance, I trained our legal team, instead of going from email, to go to Jira. This might sound like something stupid, but that's really a thing that we had to do, because basically supporting teams, especially in the legal domain, they're used to emails. And we basically said, no, emails are not end-to-end traceable. Emails will not make us certify the legal obligations that we have, like from for instance, ASPICE. You need to have everything traceable end-to-end. But then we take a next step. When we were looking at this license security corrections, we're like, hang on, we can do this within our organization, what a lot of tools do. But we're an open source tool. We can just do this internally between the various teams, because we use a lot of the same open source, but most of the commercial tools, for commercial reasons, they ask you to do this in a team level, because it's shift left. The team needs to fix them themselves. So then we said, hang on, but we use a lot of the same open source in our stack. Why don't we just set up an inner source model to just basically work on the packages, on whatever needs to correct collectively, so that we can all work on basically getting, as a collective company, as all developers work on basically making success, deliver products faster. So we started experimenting with this. In the beginning, I can tell you, when we started introducing this, the first 90 days was a little bit of a hit and miss. But once developers realized that basically the workflow was, and this is all how ORT works, how we normally say it's all like a Git, so in a GitLab or GitHub-based workflow. So basically, any developer in a company could fix any license security or package metadata issue. They would just send in a pull request or a merge request. It would get reviewed by the OSPO, or the security team, depending on what it was, and then it would get merged. So this means that you can unblock teams, they can fix things relatively quickly because they can just shoot in fixes, could instantly get reviewed, especially if in our case, my team had a pretty much 24-hour coverage, being in Europe and in India. And so then you can just quickly merge. But then we were looking one step further and say, hang on, with the fixes that we're making, we're part of multiple supply chains. And the software that we are using is the same software stack as the people in our supply chain. So that's when we also said, hang on, open source is everywhere. Why don't we work together across the supply chain? So this is where we also started sharing these corrections across the supply chain as well, because again, everybody uses the same open source. And at the end, basically, we would, and that was one of the issues where we ran into, where the same open source was used because it was decided in a program. Sorry, program is, when cars are developed, they're usually built in programs. So for a new car, there's one program set up, and that's the program name that you get. And so then usually the same stack also already gets decided. So everybody will use, say, the same version of curl. But each company individually had to report curl in the supply chain. But because everybody was using different tools, there were different results. And then we were like, yeah, no, we can do better. So I see there are already several chat messages. Let me see if there are any questions before I continue. No.
Thomas, sorry, slow reaction. How about VEX? Does ORT produce VEX documents already?
Not yet. It's coming.
Okay.
So for the people not familiar with VAX, VAX is a way that when you have a known security vulnerability reported for it, you can basically say, no, this is not applicable. So ORT already has a mechanism within it that is similar to VAX, but we're now converting it so it will do the VAX standard. The main issue, and this might sound stupid, is there was not really a good one single VAX standard. The way how VAX was developed is a little bit, too much for this topic, but it's like suboptimal. But now we are going to support it because now it's a little bit more clear, but it's still not perfect, but at least it's getting there. The people at OpenVAX are doing great work of trying to clean up and get things clean. So yeah, you will be able to produce SBOMs and you will be able to produce VAX. So you basically can, in a machine readable way, say across the support, yes, we're using this version from curl, but no, we're not affectable by this security vulnerability. Yes, it will be reported for this version, but the way how we configure it curl, it's not applicable.
So the version or it's OpenVAX you are targeting now?
Actually, we're probably going to do both OpenVAX and CycloneDX VAX.
Okay.
CSAF is on the wish list.
Okay.
But this requires, again, the way how ORT is developed, it depends whether it gets somebody willing to implement it. So that's how it is. It's an open source project. There are commercial support providers behind ORT that you can try to build certain features that you need. But most of the time for the OSPOs is basically, they build what they need and they basically work through a list of things. So I know that CSAF is on the wish list, but again, remember this is supply chain. And CSAF is not in that supply chain, but I see most of it as a requirement yet. I think it will come at some point. But for now, basically, people have they want CycloneDX or OpenVAX reporting as first. And CSAF is also a slightly different report where you meet more product focused data. But again, that's maybe way too much out of the scope. Any other questions? Cool. Then I show you now some more fun stuff. So again, ORT is on GitHub. Maybe something about I promised I would show the ORT YAML file. So we review ORT with ORT. Obviously for a lot of tools, but one of those ORT YAML files. So you see how we basically we put this path exclude. So here we indicate like our testing. And then we automatically say, especially since we are working in this field, we have a lot of different licenses in the source code of ORT itself. Normally, when you would scan ORT with ORT, it would, of course, cover a ton of red flags. And this is a simple way we can filter these out. And you can also do the similar for development scopes. Again, you might think this like, hey, this is some trivial. Now, imagine that you need to do an automatic handshake between developers and lawyers or security people. And they need to know which code is shipped and which code is not shipped. Now, I fortunately worked with a lot of lawyers and security engineers that knew a lot about development tools, but again, the code context different. So we had some products that would ship with all the test code. because it would ship to the customer and they would do integrated testing within the vehicle. So you cannot always make the assumption that everything that's used for testing is not shipped to a customer. You really need to give the power to the development team or the product owner to actually indicate this. And it might also different for different variants of the product. So this is why we introduced the thing. You asked about Vecchiari. So this is how we currently do it. So there is a way basically in ORT where you can basically mark it up in the file, and then you can explain whether a vulnerability is there. But the idea is ideally is to replace this with, you can still do this, but then there will be VEX file generated on the end. But for now, we recorded like this, and we can, ORT predates VEX by several years already. But yeah, we can switch to this model. Next, I wanted to show the ORT config repository. So this is where the whole configuration lies. For instance, again, we share the complete configuration of our tooling with the world. We don't, so that people can easily see. So here, for instance, a lot of questions like, how does license classification go? So how do you put different licenses, different buckets? And so this means, oh, there needs to be a notice file. It needs this, when you have this license found, you need to put it in the license file, and it's of classification of permissive. Now you wonder what that permissive means. Then we have, for instance, where are my evaluation rules? There. So here we have my policy as code, and here are all the licenses imported. And then we can write nice rules on top of it. Let me see if I can find a simple one. Yeah, maybe not. So it's actually a patent dependency. So if some patent wording is found in the dependency, then basically this rule says, oh, it doesn't apply to my own code, your project. If it's not excluded. So again, if not by the developer was marked that it's not in code that is shipped, that's not shipped to the customer. So when you see is excluded, basically means it's not shipped in the final product. And here you can then write a license rule on top of it. You see here also we have a license view, and that's where you might wonder what the hell is that. So there's multiple ways on how you can look at the license applicable. You can either look on the licenses that were found in the metadata. You can look at licenses that are found in the source code. You can also look at the license that was manually concluded by a user. So we have all this kind of ways that we can write policy rules. And for our default rules to KVNA in kind of ideal for the rules. So here you have, for instance, rules for proprietary software. So you see copyleft, commercial, proprietary code, patent code. This again, we have all kind of example rules we already made available. And here you see also we do it for proprietary projects, but also for open source projects. Again, I'm run OSPOs. I want to have one tool where I can review the code that is in our products, closed source products, but I also want to review the code that we basically make open source, or maybe you want to contribute to open source projects. And then, of course, you can generate nice SBOMs. For instance, here you see a Cyclone DX SBOM. But now let's look at some more interesting things. Let's see if I have it open. Yep. So here, for instance, I have, because again, I'm now working on generating SBOMs for FINOS, for all the FINOS projects, and we have 5 of them marked. And so I thought I'll show you one. Don't be scared by the huge amounts of policy violations. I haven't cleaned up the scan. So you see there's 100 vulnerabilities that have been reported. But again, that happens because a lot of this code is probably, I bet, now I can just probably look in the pods. Yep. So this is, for instance, in the dependency. So this should be shipped, but again, this is in the documentation. So this is why, again, I haven't, for these files, I haven't submitted like the ORT YAML file. This is why it's important that the developer can indicate, hey, this is documentation. So the vulnerability here is something that's documentation, might not be so important. Let me see what else we have in FINOS projects. Some interesting, tons of vulnerabilities. We have, oh, hey, here we have a license violation. So not forge. So now I, for instance, see, let me see what is the problem. So we have a GPL2 only. And yeah, and you see it's an OR. So you might wonder, why does this throw a violation? In this case, I haven't indicated my choice. So ORT has the ability, we support fully SPX expressions, which is quite unique for tools. So you can actually make choices, and you have to indicate your choice. We don't automatically make a choice. You as an ORT user have to indicate the choice, because again, as a tool, we are completely neutral. You as an organization need to make all of your choices, which licenses you accept, including what license choices you want to make. So in this case, we didn't make a license choice. I'm presumably that probably you want to use another BSD3 license, but then we accept it. Maybe I should look at more. Oh, I should click the other side. So the information is available as a table with lots more extra available information on top of it. You get the package. You can see the details of a package, how it's processed. Let me see if there's any interesting. Yeah, so you see the path, you see the licenses, and so we can really see. And we have the same information also available as a tree. You might wonder, why do we do this? Developers look at things and in this tree view. That's what they're used to. The lawyers and the security folks prefer more tables. So we have both visualizations. Let me see if I have Spring bots, similar kind of view, lots and lots of issues. But I wanted to see if I have the other scans still open. Yeah, let me just open up, because I'm still running the unfortunately I by accident deleted the deeper scan results. But luckily, I have another scan that I have. So my FINOS results were unfortunately deleted from this machine, which I'm now running them again. But I have a more in-depth one, which I wanted to show, because there are things in here that you commonly won't see. So what is unique about ORT is that it resolves everything down to source code. So for licensing and security, we have all the results all the way down to source code. And that's what you most of the time won't see in a lot of other tools, especially if they're security tools. They basically say, oh, the metadata in this package, it says, let's see what this package says. No, this package doesn't even have any metadata. So there is no effing. Let me see if I can find a nice one. It's all great. I think this project has, I will go npm. Again, the view is the same. So here you see basically in the metadata of this package, there is declared is MIT. So in the package JSON from this package is MIT. But when you actually run a scanner over it, so actually look at the source code, you find a lot more licenses. So this is the problem that I see with a lot of the security tool, SBOM kind of tools. They report the declared license in the package metadata, which is often wrong. And this really becomes a problem when you have, for instance, things like this. This is a patent license, and this is what we call an asymmetric patent license. If you do things under this, and I'm not a lawyer, but I will tell you that your patent lawyer will get very anxious when they see the license text from this patent license. And there are more of these that basically, there are some of them that I have unfortunately stumbled upon, that basically, if you use this open source, you give the creator of this open source a full royalty-free worldwide license to all patents that your organization hold. Those licenses are out there. And yes, they do exist. If they're legally enforceable, that's another thing. But let's say, yeah, you better not want to try this out. So that's why we really wanted to scan to the bottom. And another thing that for me also was always curious, I have lots of tools that run on my personal source code for my project. But most projects for 70 or 90% are now consist of open source. So I thought it was really funny that we have all of these rules in the banking, the automotive industry, where code gets tested, sometimes even every for loop and if loop gets reviewed overnight and all that other stuff. But none of these checks exist for the open source. And that's what I thought was really funny, to basically like, now we can. Now with ORT, we can just download the source code, run the same test that we run internally over all of our source code to see, hey, here are security issues. Hey, here are licensing issues. We can really detect all of that stuff. It's not just perfect, but at least that's the whole idea of having the complete corresponding source code. You can really suss out what is actually going into your stack. That's pretty much it. I think we are also running out of time.
That was great, Thomas. I've learned something today.